So the last time we left off was introduction to state machines, and we wrote a very small state machine, a very simple one, for a traffic light. So when we hit play here, you can see the state starts in the red state and then moves on to green after 5 seconds. And then it moves to yellow after 3 seconds, and after 2 seconds it goes to red, and then this cycle continues. Now, state machines are cyclic, in nature. They don't have to be. You can terminate early if you need to, but generally speaking, state machines are cyclic. So yeah. So I want to go over this again, because I think it's pretty important, and somebody asked me to go over it again, so I'll go over it again. I'll quickly go over this code, and then we're going to write it again, because I have a Unity Design Patterns GitHub repo, and I'm going to basically push it to there. So you can just clone that, and then you'll have access to the design patterns that we'll be implementing over the course of the club, over the course of the semester. So let me increase this size like that. So here is the traffic light script. And so here is the state machine that we ended up building. We actually built up to this point. We didn't start here. We built up to it. In fact, I showed you how you can create a state machine that does work. However, it's not flexible, and the code is not reusable, and we want to be able to reuse code whenever possible so that we're not constantly writing the same boilerplate code every time you want to get something done. So if you can, try and create a system that you think works for your use case, and try and reuse it as much as possible. Okay? That's how these design patterns come out, because people see that there's a pattern to solving certain kinds of problems that repeat, and they're like, hey, this pattern can solve this problem generally, right? So you just tailor it to your use case and call it a day. So we ended up building this state machine, and in the start function here, right, we initialized our state machine by adding our different states. So we have this red state for when the traffic light is red, we had the yellow state for when the traffic light was yellow, and so on and so forth. And then here, so we can say here we add here we connect the states to our state machine. So this is us registering our states. And then basically this is our, here we initialize the state machine. So we need to kick it off, right? The state machine, because this is how we built this, is super generic. It doesn't know what you want, right? It's just a template, right? And so what you need to do is at some point you need to initialize the state machine to say, hey, our state machine in this case will begin at some state. In our case, it's we want to start off in the red state. If you don't do this, then we can probably have some problems, right? And so we want to make sure that we initialize our state machines to something, right? And here is our actual states, right? We have this state type, and the state type, if we just go ahead and take a peek here, we have these four, this is an enum, right? And so we have these four things, right? We have unknown, meaning the state currently is in an unknown, right? And that generally doesn't happen, but we'll have that. And then we have this enter, meaning the state has just entered. We've just entered the state, okay? And then we have this update. This will be called multiple times, right? And the reason why it gets called multiple times is because in a state machine, you need to be updating the state machine, right? Someone needs to update it, right? And so this is a way for you to quote unquote tick. They usually call it ticks. So we're ticking, you know, the state of the program, in this case our state machine, and we're just telling it, hey, you're in the update state for this state machine. And then we have an exit. So enter and exit will only be called once. Enter when you first enter the state. Update will be called multiple times while it's getting updated, and exit will be called once right before it's about to get, the states will be changed from, basically you're leaving this current state and you're about to transition to another one. Okay. So that's what this is. And so we can use this kind of information to do a couple things. For example, if you were in a particular state and you needed to know when you're about to exit the state, you can do something like maybe save some data or, you know, raise an event. Who knows, right? So it's just some information there. And so we can capture this, and we can use a switch statement to check which state our state is currently in. It's either entering, it's updating, or it's exiting. And we basically have this for all three of our little states, right? And then an update, remember this is a Unity, you know, special method that will be called every frame because we derive from on a behavior, as you can see from the top, right? So for more information about that, see the script execution on the Unity docs. And so here we can see where every update, every frame, we're updating the state machine. Okay. Cool. So now what I want to do is I want to do this all over again. In particular, I want to build it in the Unity Design Patterns repo, so it can be saved there, and we'll even have an example, and then we'll move on. So the goal for today is, again, just go over the state machine, but then have a real example, right? So we have the traffic light, so that's an example, but something more geared towards gaming, right? And so well, I know that there's a package out there that has some animations, and we'll use the state machine to help us transition between animations. So you can see how you would use a state machine, for example, to create, you know, your controller for your character. So that logic that goes behind that. In fact, it's generic enough that you can reuse it. So we can even start, you know, maybe you guys can start making the connection of how our AI is actually going to end up working with these state machines. Okay. So go over here and create a new folder. Call it 3. Call this state machine. Okay. And let's begin. All right. Now remember, you can build a state machine that is tailored towards Unity. You can totally do that. Our state machine does not do that. Our state machine, in fact, is not tailored towards Unity. So we can actually just delete everything because I really don't care about Unity's namespace because I'm not going to reference it at all. You could if you wanted to do some like debug messaging, you know, and if you want to reuse the state machine for your own C# project, all you have to do is just delete wherever you see the Unity stuff, just delete it and it'll work just fine. So we need to use a dictionary to keep track of our actual states that we will register, right? So in C#, that's under the system.collections.generic, and this is for importing or for using the dictionary class. Okay, so public class, call this state machine, and I just like to always do system.object because probably a bad habit, but remember, all like in Java, every class extends object. In C#, it's the same thing, right? Except object lives in the system namespace, but I never say using system. So I have to say system.object. I don't need to have this though. You can have it just like that. It'll just be the same, right? So first, let's create our dictionary. Okay, and you know, if you want to have a state machine that's actually super generic, we can actually do that in a couple of different ways. So if you wanted to have a generic state machine, you could have a state machine that actually has a key, right? That you actually tell it what type of key you want to use. Okay, so you can actually say T and then, you know, oh, here we'll just call it our key, you know, or we can call this state ID, call it whatever you want, right? So you can make it generic. So in the case you're like, I don't want to use strings, strings are too slow to compare, right? And you're like, oh, I want to use something like an integer, you can do that, right? I'm just going to stick to a string. And remember, we have this in C#, you can pass methods around as parameters, and we can also store them inside of a dictionary or hash table or whatever, or even inside of a variable. And you can do that using the system.action or func. Now, action means that you return void, right? So you return nothing. Okay, that means that the return type on the method or function is void. Now, if you want to capture or contain a method that returns something like, you know, anything like an object, a number, a boolean, or string, then you would use the func. Same thing as action, except this one actually returns something. Okay. Now, we're actually going to use the func instead of the system.action that we did last time. And the reason why is because I want to be able to ask the state first if it can transition out, right? Because like, what if you're in a state where like the character, for example, is stunned, and then the player is actually making a request to make the character move? Should you transition out of that stunned state? Well, no, right? Because you're stunned, right? And so the default state for once you're when you're stunned, after the stunned state has completed, right? You should transition from the stunned state to maybe the idle state, and then let the idle state take care of the logic there to run, walk, whatever. So I would like to do that, which is different than we did last time. So it's not a complete repetition. This is now new. So we need to say that this func is going to return a boolean, meaning the method we're going to pass in here must return a boolean. Okay. So we'll just do that, and we'll call this states. Just like that. Okay. Now, another thing is we need to also have our enum. We'll call this, you know, call it state, whatever. Doesn't really matter. And remember, we need to keep track. We need to know like when we enter, when we update, and when we exit. Okay? Just like that. And so we need to pass this into our function. Now, but the thing is, we have a return type of boolean. So how is the distinction between it knowing which one's the return type and which one's a parameter? The return type is always last. So here, if I say state, I do a comma like that, this, you see where it says out? This is what's actually being returned. Okay? Think about it that way. So the state, this state enum is going to get passed into the function, and this function will return a Boolean. Okay, so let's state like that. Okay, cool. Now, what else do we need? Well, we need to keep track of which state we're currently in, right? So one way we can do this is using the string, right? Because this is the ID. So we say state ID, like that. You can either set this to null or string.empty, up to you. And we want to actually keep track of the actual method that we're actually calling, the actual state. So we say private system.func, like that. The parameter we're passing, remember, is state. It's going to return Boolean. We can call this our actual state. Set this equal to null for now. Okay. And then, you know, in Java you can have getters and setters, but in C# we have properties. So we say public string, right? And we call this the actual state ID. Say get return this dot state ID, right? So just to keep track, the current state ID of the state machine, just like that. And remember, this is where you change it. So if you know, using properties in C#, if you set it, then we want to, that's the request. We're trying to request to actually change to a different state. So we need a way to transition, and the way we do that is using a protected virtual void transition, and we say next, right? Just like we went over this last time, this transition method is going to try and transition into the next state that's being requested, and so we can put that in the set by saying this dot transition value. Again, this is all about properties. If this is like new to you, or if you want have more questions, ask, right? Or you can just look up properties in C#, right? And this is equivalent to doing a getter and a setter like in Java, but this is all in one nice little, you know, syntax sugary, and it looks pretty nice. So I like it. The next thing is we want to make sure that, well, first, let's make sure that the states that are registered actually contains this. So if it's the case that the actual register states does not contain this next state, if this is false, we return the next state has not been registered. So leave, right? Next, it does contain it. So we check if we're going to compare our current state ID and this next state. If they're the same, return. And the reason why I'm doing that is because in our case, our state machine, if you try and transition to the same state, it's just going to not allow that, right? So if you're already in the running state and you try to transition into the running state, it will just ignore it, okay? So ignore transitioning into the same state. So I want to make a note here. This is optional. You can change this to your choosing. Okay. Cool. Okay. Everything's looking good so far. So so this next state exists in our states. It's been registered. And at this point, we're not transitioning to the current state. We're going to transition to a brand new state. So it looks like things are looking pretty valid. So what's the thing that we need to do? We need to look at the current state which we have a reference here. So maybe I'll just call this current. Call this current state. You can call it whatever you want, but I'm just trying to make it so it's more less ambiguous. So I say this current state. Remember what the question mark does. The question mark will check to see if it's null, and if it's not null, it will do the following. And I want to just invoke it. I want to pass in exit. So exit, or say notify the current state that we are attempting to exit it. Now, here's the thing though. This invoke, however, because of the system.func, returns Boolean. So we need to do a check. If the current state, if I try and call exit, if I try and say exit, but it doesn't let me, meaning the state's saying, hey, you can't transition out of me, I'm important, right? Then we return, right? Because it's like you're in the stun state, for example, and you're trying to transition to like a jump. Here it's basically saying, no, you can't. You can't leave me just yet, right? Now, is this a good design? I don't know, right? So I did this because it's like, I'm using this mostly for a game, and I'll let the states handle this kind of information. But, you know, maybe you can have a way to override. You can set priorities, like, you know, very important, like transitioning from like stun to walk could be like low priority, right? But transitioning from like a stun to, I don't know, maybe like, for example, I don't know if you play League of Legends, you have like, what's this guy's name? What's that guy's name? The guy with the axes? Olaf. If like, let's say Morgana Qs him, he's in a stun state, he can't walk, right? But he can hit R and then all stuns gone. So he can override the state. So his would be like, any debuffs on him being able to run becomes high priority because you can't stun him. And any subsequent debuffs will actually notify you, be like, you know, blah, blah, champ can't be slowed or stunned or something like that, right? So you can do stuff like that. You can control that all from here. Okay. So if it's the case, then we already notified the current state that it's about to exit. So we need to grab the next state. So the actual state is equal to this dot states. Grab the next one. So grab the next state. This is a method, okay? And so we're going to update it. So this dot state ID is equal to next. So make sure you update the state ID to the next state ID. And then we're going to call it. So we're going to assign it. So we're going to update it. So this dot current state is equal to state. Point the current state to the next state, just like that. And then we're going to go ahead and call the current state, let it know, hey, we're about to enter you. It's the current state dot invoke enter. Let the state know we are entering it. Now, in this enter state, you can also do something like this. You can also say something like this dot current state dot invoke. It's possible that the state cannot be entered. Now, this is totally possible. And see, now we're getting into like this whole like, you know, now that we have this Boolean, we have all these new possible avenues we can do. Like, what happens if you try and enter the state and it returns false? What do? Now your state machine is out of sync? Do you revert back to the previous state? What's going on, right? So in our case, we're going to do that. So we're going to have to push this code right here after this. Now the reason why is because of the way we are building our state machine. So if we try and transition to, so this is the, let me call this next state, right? Next state. If it's the case that we cannot actually transition to the next state, we just hit return. Cannot transition into the next state, revert. And the way we revert, well, actually everything's fine. We don't have to do any reverts. We just don't leave, right? So nothing happens, okay? Now, if we can exit or we can enter, then we go ahead and do the following, which is update the state ID to the next one. The current state now equals the next state. And we can actually remove this one now as well. Just like that. And we're good. Just like that. Okay. Now we need a way to register the states into our state machine. So we're going to say add string state ID system.func, the actual state, and we're going to turn Boolean, call this our actual state. And so we just say if this dot states if it doesn't contain it, then we just need to register it. We need to just add it into the dictionary. We'll pass null for now. This is just adding an entry into the dictionary. That's all it is. Oops. Not null, false. And then here, we just update it. Because at this point, the state ID does exist. And now it's registered. So here, check if the dictionary contains the state ID. Since it does not, add an entry into the dictionary. Update the entry of the dictionary with the new state. And then we can also remove. When you're writing code, every time you have an add function, you should always have a remove function, right? We're just going to say this dot states remove state ID, just like that. In fact, I don't even think you need this. Just like that. And then we need a way to update the state. And we're just going to say this dot current. Use a question mark to check to see if it's null. And if it's not null, do the following. And what are we doing? Tell the state to update itself. That's it. There's our state machine. Beautiful. Now really quickly, I'm going to go to the top here and add the class attribute of serializable. That way in Unity, we can actually look at this state ID and we can watch it transition. Okay. Cool. Not bad. Not bad. Okay. Now, for the real test. I believe I have this folder structure. I think I'll make an example. Yes, I do. Okay. Now, let's make an example folder here. Or I'm going to make an example folder. I'm going to add a scene. Where's my CNet? There it is. Okay. What am I calling it? Okay. Cool. Now let's go to the asset store and find a pretty model. Not that kind of model, like a game model. I don't know, maybe the model is a model. Who knows? So let's find some, well, free is always good. So let's click on free. And let's look for a, I don't know, some 3D stuff and something that has animations. This one? Sure. Why not? Let's check it out. What is this? Unity Chan? Little Swans Playground? What is this? Does it have animations? All I care is it doesn't have animations. It has 31 animations and 31 poses. So, because you guys are giggling so much, yeah, let's just use this. Why not? So we're just going to go ahead and download this. And as usual, I forget my password here. Or actually, dang it. Okay, I forgot my password, so yes, very excellent. I mean, look at me. Yes, of course I want a donut. Oh, the heart one.
Somebody got the pink one.
Nice. Thank you. All right, so let me go ahead and just change my password here. Apologies. I'm not that good with this stuff. All right. Resetting password to password 123. I mean, no, don't do that. Okay. Okay, I don't like that in Unity, when you reset your password, it doesn't give you a confirmation dialog box. So what if I misspell something when I'm setting my password, then I'm screwed again, right? So, well. All right, not bad. Cool. We're in the mainframe. All right. So, I don't know why this is funny, but we're going to use this one. Cool beans. Or cool donuts, right? All right. Import Unity Chan. That's Japanese, right? Chan at the end? Or the sun? Japanese? Okay. What's Chan mean? Oh, cute. Ah. Interesting. All right. So I'm going to import this whole model. Now, the whole point here is actually to basically like show you, because this one has 31 different animations, right? What those animations do, I have no idea, right? But you can start to think, okay, this can get quite complicated, right? So having a good state machine, or having a good backbone for a state machine can help you, right? So maybe this character has 31 animations, but they're like attacks. And it could be different types of attacks. Like maybe you have like a ground attack where you're just standing there and you're attacking. Maybe there's attack animation for when you're running and you attack. When you're in the air and you attack. You see what I mean? Like maybe it's an attack while you go into the air. So the number of animations will increase depending on when you actually want to do attack. Maybe you want to do a parry, right? Maybe you have different types of parries. So like you're not always doing the same animation. You can actually randomly choose which animation you want to use to do a parry. Or if you have like a basic attack, instead of just swinging your sword, it's still a basic attack, but you can use different animations to give it that feel like it's organic and just randomly pick or, you know, do stuff like that. So, oh, and there's voice. Nice. So she'll be attacking and being like, yeah, or something. I don't know. I'm very curious about the audio. So. Yes. We will change the pitch. Now, so I think that's done. So I'd like to make one thing clear, you know, and oh, did I mess something up here? Probably, but I might just delete it or whatever because I'm not gonna use their scripts. I don't care. Well, this one actually makes sense. Auto blink. So like the eyes are gonna switch textures for her blinking. I don't really care if she blinks or not. You know, she can have her eyes open all the time. You know. Okay, it's in Chinese. So, oh, I know. We might be able to solve this by switching our .NET type. We're on 2.0. We can go to 4. Here we go. Not sure why he needs policy for that, but we'll see. There you go. That solved that. So, all right, I'm not going to go over what that means just now, but yeah, just know that, yes, that basically worked. Now, the only reason why I know that is because, well, I do a lot of C# coding, so I know that that's in the 4.0, so. All right. So let's inspect this new package that we just got. It's in Chinese or Japanese, I think. All right, it's in Japanese. I'm sorry. Cool. So there's our Unity-chan. So let's see if there's any menu. Okay, cool. Nice. Very nice. So face update. Smile 1. If I hit spacebar, oh, I see. So she has animations for like running sideways. So example, like let's say you have a gamepad and you're pushing forward and to the right, right? There's a slide, so like you're running and then you slide. So you see all these animations? So I can see what, okay, that's cool. We're back to idle. Okay, I thought she was gonna bow, but she's stretching. cool, right? So it's not bad. Midnight, right? No? Not how it goes? Okay. All right. So let's build a state machine for her using our state machine. And let's do our state machines where like we press different buttons on our keyboard and it activates like dance moves. I think she has some dance moves, so let's figure this out. I think there's audio on this too. So here she is. And so this is actually pretty extensive. So let's inspect under animation. Let's look at the animator. Wow, so this state machine is pretty complicated. Let me just blow this up real quick. Okay. All right. So this state machine is quite a lot. Remember, there's 31 animations, right? And so remember, the orange one is the default one, yeah? It's the default one. And it looks like, let's see if there's any parameters. So there's just this next and back. So we can actually look at these. So let's see how this person built this. I don't have a mouse, so it's kind of hard here. All right. Chetos, don't want to do that. No, all right, cool. All right. So in the inspector, it looks like conditions, back is true. Okay. This one is next. Okay. I see. Okay. So it's not this is a demo animation state machine. Basically, as I hit the space bar, it's just gonna go to the next one, to the next one, to the next one. That's what I'm assuming. That's why I was hitting the space bar and it was just transitioning between animations. So it looks like she started here in this jump. And we click on this, we can actually click on this. And then here in the inspector, if we click on this, you can actually see the bones here. Let me zoom in. There is a character here. And we can actually skip to this timeline and check, right? So this is kind of freaky, right? So I'm just gonna go ahead and just drag this entire thing in here. All right, let me try another one. Oh, I see. Ooh. So each animation, from what I'm picking up here, is it's in its own FBX. So we don't have a whole model that we can actually use. Okay, so that's not cool, but yeah. But anyways, you can see here the bones are animating, and that's kind of the point. What's that? Yeah. Because you can see, like, here are the actual, like, this is like, I think that's the torso. This is like the torso, I think. So I think that's probably what's going on. But anyways, regardless, doesn't matter, right? So this one's interesting, though. This one's are the faces. So I'm going to assume that if I go to her head, this is not her head, right? This animator is on the entire body. This is what's called an avatar. So click on this avatar here. We click on this. If we go on to configure avatar, remember, so this is basically an introduction to bones and how these things work here. This is an avatar. So the person has already rigged this. So if we go to the scene view, we should just see the model here. And this is an example of how you should be rigging your characters. So here are the bones, right? So right now the character is in a T pose, right? And the modeler had already created what's known as a rig, and those are the bones, but they're also targeted towards specific parts of the model. for example, like the hands. So this bone over here, and in fact, he actually has bones for the fingers, right? And he has bones for the hair. So the animations then are going to target those bones, and those things are things that actually move. Now notice that the hair bones and her chest bones, I think these are her chest bones, they're not green. Why? Because this is an avatar for what's known as a humanoid. So if you have, like, let's say, I don't know, like a mech that has human-like structure, like is a biped, for example, then you can use this avatar to actually have the bones be targetable. And this way, you can actually use reuse animations that only target bones. And the cool thing is, those animations now become basically universal in a way, because all they're doing is animating bones, and you have this avatar to say, hey, you know, this object right here, if you click on this, that's the left foot, the toe base. You can just click on these ones, you can see it highlighting. So her hand, for example, if I click on the hand, there it is, the right hand, right? And then here we get all the index fingers, right? That's pretty cool, right? See? And so this is like, if you're going to do a really complicated animation for your characters, then you need to go down to the bones, like to the fingers as well, and even the toes, right? As you click on here. So this one doesn't have anything with the toes, but you could actually animate the sole of the foot to actually bend, and then, you know, in the animation it wouldn't look so good because it might clip through the planes, but then you can use a process what's known as inverse kinematics to ray cast and actually stick the foot to the ground. So it almost looks like the animation is a one-to-one, but it's not, and you use different weights. So maybe we'll hit that at some point, or maybe not. We'll see. Anyways, I just wanted to show you that. So that's pretty cool, right? So if you're into modeling and you want to get into animation, then you should look at other people's work, see how they did it, and find out why, right? And so if you want to have an animation, you can't just have a character and just be like, yeah, I want to animate this. Like, that's not the right way to do it. The right way is just to create the rig with the bones. That's the hardest part, rigging. Because once you have that, any other animation that animates bones, you can just slap it onto your model and it'll just work. It's called retargeting. Okay. Anyways, so let's go back to our scene here. Let's go to our example scene, and let's look for a prefab. And this prefab right here has our character. So I'm just going to drag this character into our example, and I'm going to move her closer to us like this. Then I'm going to rotate her 180 degrees on the y-axis to face us. Okay. Now, all the scripts on here, like the face stuff, I don't really care. So this is a prefab. I want to create my own. So starting in Unity 2017, I believe, they basically remade their prefab systems. You can have prefabs inside of prefabs, so not that important, but, or for now. But anyways, I need to do what's known as unpack. So I'm going to right click this, unpack the prefab completely, right? Now it's, you know, gray, not blue anymore. I'm going to just drag this in here, because I want to create my own prefab. I don't want to mess with the other prefab that they built. I want to create my own, so I can like mess with this and I can break this and it's okay. So this is a copy, okay? So I'm going to delete stuff. I'm going to delete this. I'm going to delete this. Delete that, because I don't care. And I'm going to delete the animator, because I don't care either. So I'm basically starting from scratch here. I'm going to hit override, hit apply. There, gone. Everything's gone. Okay. Cool. Now, start playing with some stuff here. So, I need to create a, what is she? Unity Chan? So we'll just call this our, I don't know, actor. She is our actor. Okay. Now, this is Unity specific, so make sure we have Unity Engine. Now, this actor is going to be abstract because it's an actor. Show me an actor. You technically can't show me an actor. I mean, you can show me, George Clooney. He is technically an actor, but he is not the actor. Actor is an abstract idea. Same process here, right? You can't show me a human. You can show me a person that is a thing that is also a human, but you can't show me a human, nor can you show me a car. These are abstract ideas. Same thing here. Now, basically, I want to set up is I want to say all actors need to have a state machine. So here we go. So private state machine equal to new state machine, just like that. Now you might be saying, well, it's private, so how am I going to grab this? Good question. You can grab this by a public way of grabbing it. Now the reason why is because, well, should you do it this way? For now, yeah. We'll say public state machine. Call this state machine. Just like that. Return. Just like that. A lot of state machines, huh? Yeah. All right. Cool. And that's and I want to say that now at this point I shouldn't really have to explain what awake is. You should know this by now. But if you have questions, just look it up, and you'll find out what awake does. Okay. But if you have questions, let me know right now. If not, look it up. All right. Now I just want to say that every actor will have at least one state, and we'll call this the idle state, right? So I'm going to say protected, virtual, bool, because our funcs will return a boolean, right? Because we need to know if the state is in a state to transition out of. So when we say exit, can we actually exit? If we say enter, can we actually enter, right? So I'll call this state underscore idle. That way I know which ones are my actual states. So I'm going to prefix it with a state. You can also postfix it with a idle underscore state or something. I don't know. Figure out the way that works best for you, or if you're working for a company, ask them. Do we prefix? Do we postfix? What is the naming convention for our states? I'm going to do it this way, just to make it clear that this is a state and not a regular method. It's not a helper. It's not. This is a state. Okay. And then I'm going to say state machine dot the actual state. Now that state is actually the state's state. Every state has a state. Enter, exit, update. That's, I know. Okay. And for now, return true always. Right? Just for now. Okay. So if somebody wants to enter, yes. Somebody wants to exit, yes. You want to update, yes. Okay. Because idle doesn't do anything. Okay, cool. Now, I also want to make it clear that every actor must have an animator component for our animations, right? So how do I make that? How do I enforce that? I go to the top and I, decorate this class with a require component type of animator. Now again, this is coming from Unity. Basically, force every instance of actor to have an animator component. To learn more about require component, you can look here at the Unity docs. I highly recommend you looking at the Unity docs. You can literally say like you can say require component Unity 3D, just like that. And then bam, there it is. Go ahead and read that. Want to know what animator does? Animator, Unity 3D. Bam, there it is. You want to know what type of does? Type of is a C# thing. So you say type of. And there it is, C#. Look at the MSDN. So we're going to postfix this with MSDN. There you go. All right, so right here. Docs, perfect. And then go ahead and read that if you want to know more about what that does. Cool. And then, so on awake, I'm going to say this dot state machine dot add. Okay. We have our idle, and I'm going to register my state idle to it, just like that. And then when this script has loaded, so after awake, on start, I want to say state machine, state ID, start off with idle. Just like that. So this is going to say basically initialize our state machine to idle. That's it. Not bad. Register idle to our state machine. So far, so good? Yeah? No, nothing bad? No? Cool. Moving on. So what do you want to do here? Well, check the state of the state. If we enter it, if we're about to enter our idle state, we're just going to, we need to grab our animator. And the way we do that is first cache a reference. We'll call this anim. Set this equal to null. We'll say public animator with that. Say if this dot anim equals null, this dot anim equals this dot get component animator. Return this dot anim. Now, what the hell is this doing, right? This is just a property. I'm going to grab this animator component using the property syntax sugar that C# provides us. And I'm basically saying, hey, if the animator is null, go ahead and grab it. Now you might be asking yourself, why don't you just do it in awake? Why don't you just do it in start? Good question. And the reason why I don't do that is because what if I write some editor scripts, right? I might want to do that. Why? I want to quickly iterate through these states, right? The animations, and I just want to hit a button so I can just see it in action. But I want to be able to do that without actually running the game, hitting play. Maybe that takes too long. I just want to just quickly check. This will allow me to do that. And we'll go over editor scripts later, but this is just in preparation for that. Cool. So then all I'm going to say is this dot animator dot set. For now, we'll do it using triggers. We're just going to say idle. And that's it. Okay. Now we go back. So there is our actor. And I'm going to call, you said Chan means cute? Yeah. Okay, so we say Chan. Our Chan actor, our cute actor, whatever. Cool. And now this is some polymorphism, right? With this inheritance stuff, right? A lot of cool things we're about to do here. So again, this is going to be Unity specific. Public class Chan extends actor. So Chan is an actor. That's pretty cool, right? And Chan can have more states. How about that? For example, well, I need to know what states we want to use, right? The states are going to be dependent on the animations. That's how I'm trying to build this, right? So let's go over here. Let's look at our what would it be under art, I guess? Yeah, animations. So we have this jump. Is there an idle one? Which is just like just idling. Maybe the wait ones? Whoa. That's creepy as hell. If it's just her bouncing, yeah, that looks like an idle animation. This is a very bad example because I don't see anything, so it's kind of hard. Usually you can actually see something. You should be able to, but I guess here you can't. Ah, look, this one's a waiting one, just idling, just waiting, just like that. Cool, right? So there's a bunch of waiting ones. In fact, when we're in the waiting state, we can actually randomize between which waiting animation plays. We can actually do that. We won't do that right now, but we could. All right. So we would have time? Yeah, I think we have time to actually be able to do that. So I want to have a hand up. What is this? Oh, that's just, okay. Win. This is very bad naming convention. I don't know what any of this stuff is, so. Oh, win, as in like they won. So like a cheer. Oh, that's a cheer. Okay, that's a cheer. Cool. All right, let's go back. We want to have a win state. Oh, like a fighting game. After you win, what happens? Like in Tekken or something like that? You know, there's like, right? That's what we want to do, right? So we'll do that. So let's make a win state. Cool. And we will always return true. And all we care for right now is when we enter. Again, this is actually a bad way of doing it. You wouldn't want to do it this way, but I'm just for now. Okay. We need to register it though. So on override awake. So we're going to use awake to register our states. So it's .stateMachine.add. Call this win. State win. Man, not bad. All right. I saw one that was a jump. Let's register that one as well. Make sense? So far, so good, yeah? Cool. Now, we need to hook up the animations. So how do we do that? Well, let's add our Chan. When I add Chan, what happens? The animator component came with it. Why? Because the Chan requires that this animator component exists. Now there's one thing we need. We also need under the models here, we need the Unity Chan avatar, or else these it's possible these animations may not work, right? So we need to do that. Okay. And the controller, we will make a controller. Okay. So how do we make a controller? Let's go over here. Create animator. Where's the animator controller? We'll call this Chan, just like that. And we're going to link it to this one. There we go. Okay. Now, what is the animator controller? The animator controller is a state machine for animations. Like Kelly had brought up a point. Can we use the animator controller to build our state machine? Yes. But this is more tailored towards animations. It now supports behaviors, because a lot of people like Kelly had brought up the point, well, why can't we just use the state machines to do some logic for us too? And they said that's a great idea. So they actually added state behaviors. When I said, when you go to the idle state, we can actually randomize which animation clip it plays. And you can achieve that now through state behaviors. You can just create one behavior called randomize, and when it enters, you give it a list of different animations that it can play, and it'll just randomly pick one, and they blend. Very, very cool. Okay. So, how do we do this? Let's create a default state. And this one will be our idle state. Call this one idle. Motion. Motions are your animation clips. Okay, so we find one. So we have the weight. So we'll just drag that in here, just like that. Okay. We want to add another animation state. Remember, these are animation states. We have a jump, right? So we can click on this, call this our jump. And I saw a jump around here. Jump. So let's just, grab this one. Because why not? And then we had a win one. Call this win, and right here. Cool, easy peasy, not too bad. Now I had this thing called triggers. Now these triggers are what's going to actually trigger which animation to play. Now I said you shouldn't do it this way. Now the reason I'm going to do it this way is just to demonstrate a point. The way you should do it is using like IDs. And the reason why you want to use IDs is because each state can actually have some logic attached to it. Every time you stay inside of the animation, it's going to constantly check the parameters. So if, for instance, you have a Boolean saying is in air, and you want to play the in air animation, as soon as you're no longer in the air, it can actually check for you that you're no longer in the air. And then when you switch off that Boolean, it'll actually transition out of it to something else, maybe the idle state or something. So you can do that. Right now, though, I'm not going to do that. I'm going to create these links from any state. Again, very bad. Don't do this. Okay. How am I going to transition into them? What's going to be the quote-unquote trigger? Well, now we need to create all these triggers. So the first one was the idle trigger. The next one was the win trigger. And the other trigger was the win trigger. So to go into the win, now we have our animation here. Here we go. Whoop-ah! Right? See, now we can actually see our model here because it's actually attached. So let me make this bigger. Let me try and zoom in. Okay. So we can actually hit this timeline. So this, what I'm scrubbing here, is actually trying to blend between the idle and the win. See that? There's the idle. It's idling, 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 and then bam. So the actual win starts here. So, but what happens if you want the win to just happen automatically? Just kick it off. And you don't want to blend between it. Here is a jump. Should you be able to go from a jump to a win? Well, this is how it looks like blended. You're jumping, and then you go into the win. See how it blends automatically for you? See how it's blending? You're jumping and then whoopsie. And in fact, you can actually move it. So when you're in the air, when her hair's like that, I'm gonna push this over here and look what happens. So she's in the air and then going into this wind. See that? I can even push this even further in like that. Let's see what happens. I think I need to push this back. Yeah, I need to push this back. Okay, now let's see what happens. It might look all janky. Jumping, and then it's really weird. You see how her feet were in the air while her hands were, you know, it's trying to blend. See, watch. She's jumping, right? And then it's trying to go into the wind animation and like, look at the feet. Look at the feet. She's like in this weird floaty stage. You have to be very careful about how you blend the animations. Can you guys all see that? So be very careful about how you blend these animations, right? So just be careful. So this is how Unity is going to try and do it by default. Okay. So it says conditions here is empty. Hey, I don't know how you want me to transition. Well, I hit the little plus sign and then tell it, hey, transition here. Oh, not win. This one should be win. Oh, I'm sorry. There should be a jump one. There we go. So I want to transition into my win on the condition that the trigger win happens. The jump one, click on the white arrow when you actually want to jump, and transition back to the idle when the idle trigger is triggered. Okay, cool. Now, because of my state machine, I should automatically kick off in the what? In the idle state. So if I hit play, it should just work. We shall see. Hit play, see what happens. There she is in idle state, right? See that? Pretty cool, right? Now, in code, I am going to trigger these. Now let's see what happens when I want to trigger, for example, the jump. There she is jumping. If I want to trigger the win. See that? What happens if I try and transition into itself? So a win into a win. Look what happens when I keep triggering inside. See, I'm keep triggering it. So I went from a win to a jump. See? Now let's try and control this in code now. So that's pretty cool, right? See how we can transition, right? Cool. Now, I forgot one thing. Our actor needs to update our state machine. Okay. Now let's go to our little chan here. Now override, update, base, let the base class update first. Because it's going to update the state machine. So we need to do some checks. Let the state machine update first, and then we're going to do our stuff. Now, we're going to do this using our keyboard. I'm going to say if input, dot get key down. Let's say they press the A button. Or actually, let's make it more sense. If they press the J button, that should be the jump. So this dot state machine, state ID is equal to jump. Transition into the jump state. If input dot get key down, key code dot w, let's say that's the win. Transition into the win state, whatever this is, right? What was the other one? Idle. If they press I, transition into the idle Again, this is not how you would do it, but I'm just trying to show you. So J is for jump, W is for win, and I is for idle. Hit play. Let's see what happens. So if I hit J, and I'm going to go here to my inspector, I'm going to right click on it, go to debug, and open up my state machine. Right now it's in the idle state, which makes sense. Why? Because the actor initialized the state machine to the idle state. So if I hit J, should go to the jump state, and hey, look at that, it jumps. What happens if I push J again? Nothing. Why? Because my state machine will reject. If you are already in that state and you're trying to transition into the state again, it gets rejected. So if I keep hitting J, nothing happens. Now I'm going to hit W. Now I go into the win state. Look at that. Back, hit I, she transitions to the idle state. Jump, win, I, jump, win, I, jump, win, I, jump, win, I. Right, back to idle. Right? Now, so you can imagine how you could control this, you know, for like a character. Right? This is the basics now, right? This is not, you know, this is at least showing you like the stepping stones of what you could do, right? Now you can control the animations through the state machine that we just built, right? So let's go a step further. All right? Let's make her move. All right? So I need to what time we got? 4:25? All right. Does she have some running? Yes. Oh, and she has walking. Walking back, forward, walking left, walking right. The way I can tell is it's postfix with a B for meaning walking back, so she's backing it up. F for forward, so she's moving forward. Left, meaning she's walking towards the left. So on and so forth. Okay. So let's try and let's see how we can make this work with our little setup. Again, this is not the way you should do it. Absolutely not. Do we have time to do it properly? Let's try and make the walking at least properly. Now, how do you make it properly? Use what's known as a substates. So if you right click here, go to a create substate machine. Okay. A substate is, you see how we have this right here? Each substate has its own thing. So this one is called, let me right click right here, inspector. I will call this locomotion. Okay. Locomotion will have my walking and my running. You cannot run until you walk, right? Some games are like that. Like when you push the thing forward, it transitions you first into the walk state, and then it'll blend into the run state. You can't just go from idle to just running, you know, unless you have like a super booster, and then like maybe that's a special state though. So a lot of the times they kind of like enforce this. Okay, you can't, you know, you have to be walking and then you can run. Okay. So let's see how this will work. So I am going to, for example, what's a good example? Let's say you're playing a fighting game. Like when you crouch, you have that low kick. You can't do that if you're jumping, right? So how I say you can only run once you start walking. You can only low kick only when you're in the crouch, when they're crouch state. So that's what I mean by it. So maybe that's a better example. Okay. So I'm gonna set the local. I'm gonna drop the. Well, I can just keep that here, I guess. Inside local motion, I'm gonna create what's known as a blend tree. Okay. Now this is gonna be pretty cool. Now, the reason why is because here we have this blend tree. I want to blend between walking forward, left, right, backwards. Actually, I'm just gonna do it for. No, I'm gonna do it for all of them. So I'm gonna call this blend tree walk, and then, okay, here's my blend tree. Double click on that. So right now she's in this like very like distorted, pose. So I'm gonna add some stuff here. I'm gonna create add motion field. Okay, I want to add the walk forward animation. So I'm gonna drag that in here. So there she goes. Just like that. And there it is. See that? Just walking. Let's add another field. Add motion field. Now you see this whole thing just happen. What is this? Oh, you'll see. So now we have forward and then let's say left. Okay. Now this blend type needs to be a 2D simple direction. Okay. Now you're gonna move forward when the Y is 0, 1, or hold on here. Yeah, right there. And then yeah, and so I'm gonna change this L to back. See that? Okay. And so now I need some blending parameters. Now this one I only have one right now, so let me go up one. Go back to this walk. And if I click on the blend tree, parameters, I need to call one X axis, another one Y axis. Okay. Now we can create, let's see. It's been a while since I've used this. Where do I create the oh, yeah, there it is, right here. Move this to X axis and then create another one called float, Y axis. There we go. And then yeah, so this is on the X. You can see how it's changing, and that'll actually change our animation. So right now, see if I can grab this. You can see like that. as we change these weights, it should change the way she's looking. Oh, why isn't it changing? Because I just want to, just specify, hold on, float x-axis, float y-axis, and just delete this one, delete it. I just want the forward one to be on the y-axis. Because on the 1D it's pretty easy to do this. See, because this only has one axis, so if I were to just do y-axis here, how do I do this again? Thresholds, no. Forward is 1, back is -1. And so if I go into this y-axis here and I change this to 1, she's going forward. And then it's glitching? Yeah, it's probably glitching. I don't know why it's doing that. Ah, this is what I wanted. Yeah, see, if I click on this, oh, I can't see it anymore. But this is what I wanted. Oh, there we go. Hit play. See, if it's -1, it should be walking backwards, which she is. And then if I go forward, she's walking forward. That's what I wanted to see. So I think it is. I think the spectre view looks weird. All right, but you can see how it's transitioning between the two. Now, if you're at 0, if your y-axis is at 0, you shouldn't be moving at all, right? So the threshold should be that, but it needs to be greater than. Yeah, you're actually right. It should just be integers, huh? But can you do it? Yeah, you should be able to do an int. Alright, can I change the data type here? Nope, just delete. Let's try with an int. All right. Anyways, it's been a while since I've used these blend trees. But I want to make it so like if it's all right, see. So anyways, so for our local motion, what we're going to do is when you're idle, I want to transition into local motion. Particularly, I want to go into the local motion only. Add behavior. Conditions. When the y-axis is greater than 0. Well, in this case, it's an int, so greater. If it's see, that's why I wanted to have a float. See, because with the flow, I can say greater than 0.1 or less than 0.1. Basically, that's what I want. Is there an absolute? Yeah, there's not. Yeah. So I'm gonna just do the float y-axis. It's greater than 0.1. Conditions. Y-axis is less than negative 0.1. Right, I wanted to just be able to like move forward or backward because I'm going to use that value to go into the local motion and blend. So only from idle can I go into the actual walking stuff, right? Okay. So let's try that. So let's go over here. So we need to now have a walking state. So I don't actually care when I enter. I just want to update first. Okay. Now, okay. So I'm walking. The way I'm going to exit is it's going to be like this. So first, I'm going to grab the inputs from the keyboard. Okay. So I'm going to say var. Oh, I'll say all right. Y-axis input.get axes, and this one's called vertical. This is going to basically be on the WASD keys, WS, or up down on the arrow. Okay, return true here. If mathf dot absolute value of the y-axis, if it's less than 0.1, I basically need to say, hey, state machine, go back into the idle state. We're no longer moving. Okay. I'm going to hit a quick return here. Okay. Else, as we're updating, oh, not the state machine. Tell the animator, hey, update the float value. Which one? Y-axis. Pass in the y-axis. And then let it handle the blending. Right? Because when you're in the idle animation, so in this case, we're going to go from idle to local motion. And the actual state, you saw that only if it's greater than 0.1 or less than negative 0.1, that's going to go back and forth. So it will handle it. So it's pretty good. And that's it. That's really it. Now we're going to have to update our idle state. And because we inherit it, we just override state here. I'm going to say switch state. Okay, case update basically do the same thing. Y-axis is equal to input dot get axis vertical. If mathf dot abs y-axis is greater than greater than or equal to, we're no longer idling. We need to go into the walk state. So we're going to say, hey, state machine, go into walk. We're walking. And then from walking, if you're between like 0.1 and 0.5, you're walking. If you exceed that, you're now running. So you're walking and then you're running. If you're walking backwards, you're walking backwards and you're running backwards. Stuff like that. Okay, cool. And that should just be it. So let's see how bad this is going to be. So let's look at our state machine here. Right? Here's our state machine. It's idling. I'm going to press my W. Oops. W, it has the, well, actually use the arrow keys. Let's try and use the arrow keys. Right? Let's see here. Vertical, horizontal. Do a quick debug. Log the y-axis. See what's going on. Oh, that's not the problem. I didn't register them, right? I need to register them. Duh. I need to register the walk now. Why didn't you guys tell me? You guys didn't tell me. I'm like, what the heck? Okay, here we go. Pushing on the y-axis. Let's see what happened. Greater y-axis. This should be blending into okay, so let me remove this. How do I remove this? Because I want to go right here, click on this, remove that. There it is. I think I actually need to make a transition into, wait, no, that should have been it. Okay. Oh, right. Okay, so my bad. So let's just delete this. We want to actually blend into our walk because the walk actually has the it's the actual blend tree. So we're going to say if the y-axis is greater than 0.1 or if the y-axis is less than 0.1. All right, that should be it. Because the local motion, remember, can have its own logic. In this case, it didn't have anything. So you want to push it into the actual Because we're just stuck in idle, it's not actually leaving. So that's odd. Let's look at our, maybe it's not transitioning. State ID. Oh, it's in the walk for sure. So it is walking, but it's not. Oh, it is blending.
Maybe it's not transitioning to the actual animation. You do have exit time on it. Exit time?
Yeah, okay, let's try that. Because it looks like it's just cycling through idle, it's actually not leaving it. Though I don't think we could try that. Interesting. Blend tree parameters. Right. But it wasn't here. It actually did move it in here. So I'm kind of like.
Yeah, the blend did, but the transition didn't. Transition was still saying it was there.
Let's grab this walk and then
Have you tried going from inside waist to empty the walk?
yeah, I'm gonna just try and pull it out and see what happens if I just go directly into it. Maybe it has something to do with, like, I don't know, you're going into a different layer. No, it's still not blending into it.
The blend tree parameters on the actual in the expected. No, on the transition itself. Blend tree parameters. Just Y axis is there.
Okay, so let's try one. I shouldn't have to.
Maybe it's because you switched it around between integer and float, so it created its own within the transition.
The problem is that it's not even moving from the idle to the walk. That's like the main problem. Let's make this I'm gonna make the walk the default state and just want to see what happens.
Oh, any state is going to idle.
Well, yeah, they're all because it's they're triggers, right? But it looks like the walk, however, the actual walk is leaving. Idle to walk. There's a blend tree. I'm obviously doing something wrong, but it should work. I mean, you can see it actually working. It's not hooked properly, but you can actually see that it's actually it is blending, like. Like you see the y-axis right here. It's actually updating it. See. So let's we'll just create a boolean here. Double transition. So this one, we don't need double. Just remove this one, and call this walk. Well, if walk is true. You know what? You might be right. I think we should just say walk to be true, and then we switch over to. Actually, I think you're exactly right. I think I'm an idiot. Yeah, I think I'm an idiot. Let's hit walk. There you go. And there we have it. Okay, I'm an idiot. All right. Cool. So we can put this bad boy back in here where it goes, and then all this stuff now makes sense. Because I've never done that before. So because I usually use an integer for the states. I know when like walking with idle is 0, walk is 1, run is 2, and then because I use an all right, doesn't matter. Anyways, so now how do we transition? However, well, I guess we could say walking is true, and then from here we make a transition to exit when walking is false. Is false. Just like that. Okay. So how do we do the last fix on this is here, case, enter. We're going to say this dot animator. Dot set bool walk to be true. Okay, copy this, and then walk equals false. Okay. Now with that, we should have it. Should have it. Although I gotta switch it back to default to be idle. This should be the default. Okay. So by default, we should be in the idle state. Okay. Here I'm walking. Ah, see now it's transitioning, and I let go. Okay, and then I hit I. Just walking backwards. Right. So one thing I'm noticing is that the actual y-axis is we should update this one more time. Set float y-axis just in case. All right. So now we have a walk. And we can also have a run, like if it's greater than half, we go from a walk to a run. So we can also do that. Oops, I hit W, hit I to go back. So I want to actually add a transition. So here I had removed that, so it has exit time. Yes, transition duration, I believe it's under 0.2 is the defaults for all these ones. 0.25. 1.25, just like that. All right. I don't want it to look all jerky, like going from idle state. I want idle state to actually transition. See? I don't want it all jerky. So I just need to remove the has exit time, or remove that. Oops. And I'll make it so, because I want it to blend but not take too long. There we go. That looks good. There we go. So it's blending but not taking too long. See that? So I don't have to wait for the idle animation to complete in order for her to transition out. And in fact, we can even play around with this by going to the idle. Here's the wait. There's some other wait ones. So wait 0. Let's try that. Plug that into there. Remember, these are different types of weights. So maybe next time we'll play around with this. There's a wait one. She's just waiting. And here we are walking. See how her hands went down? They didn't just like snap into place. And then here she's waiting again. This is idling, right? And then now I'm walking. See how it blends? That's pretty good parameters. Blend, walking. And from there we can even go into the win. See how her hands were already kind of there, so they didn't have to blend too much. So there goes idling again. Hit jump. Go back into idling. And there she is, you know. Into the jump, or to the win. Right? That's pretty cool, right? Cool. All right. So I think we'll call it there. So we'll end it there, and then next time we'll continue working on the state machine. Maybe have her walk, but 2D, right? Left and right. I have to look up why it wasn't working, and I'm pretty sure I did something stupid. Pretty sure. So all right. So yeah, I'll make sure to push this on GitHub, and this will be under the Unity Design Patterns repo. All right. Cool. See you on Tuesday.